Welcome to the first Defichain source code review video. As always, start off with the talk of town in the Defichain community, the Fort Canning Hill update, and the main feature, the implementation of the DFIP 2112, which intends to bring the DUSD closer to $1. The DFIP itself is a lot of explanations, but basically comes down to two major points. It's every DUSD loan should be repayable with DFI at an Oracle price plus 1% penalty, and the DUSD can be used as collateral at a fixed rate of 99 cents. So let's see how this was implemented. If you want to review the stuff, you can go to Defichain, which is the repository for the source of the full node. So where the mining happens and all the verification happens. And here you see in the releases, we have this latest release, the 261, is the Fort Canning Hill update. In these release notes, you have all the description of what happened, what changed, changes to the RPC, cores, and everything. And then you have the features. And here we have our main point of interest, payback of DUSD loan with DFI. And the other thing, and that's an interesting part, is using DFI as DUSD as collateral. It's not a feature, it's not a fix. It's actually, where is it? Here. It's actually just a test that was added because this was possible already before the update. The thing is that which tokens are possible as collateral, which token is possible to be minted, so what are loan tokens and the parameters of those is not part of the source code, but it's part of the chain state, so to say. So they can be activated, deactivated by special transactions. You need the authorization to do that, and very few people have the authorization to do that, or very few addresses, but you don't need a source change. So to activate that, there was nothing to be done. It was just added as a test to make sure that everything works as it should. So let's start with that one, because then the other one, let's save the best for last, right? So if you want to review stuff, go into the pull request, because every feature is done as a pull request in the repository. And in this pull request, you see what's happening. There's changes, discussions, and so on. And then you see what actually changed in the files. And we see it's 104 lines. It's basically one new test came in, one new test file, and this is a test file. One note, the source itself is mainly C++, but the test framework is in Python, so that's why this is a Python file. So let's just quickly look through this, what's happening here through this test. It's basically setting up the chain, setting DUSD as a loan token. So that's doing the transaction on the chain that activates the loan token, generate a block, get a new address, appoint oracles, set collateral token DFI, so that we have now the current state of the chain, or what we had before Fort Canning Hill. And then we have this transaction that we say, okay, activate DUSD as a collateral token with the fixed oracle price of DUSD and the factor of 0.9 in this case for the test, and activate it after now plus 50, so that we also check this. It's not activated right away, it's activated after a certain amount of time or a certain amount of blocks. Then it creates a loan scheme, creates an address, a vault, gets some loans, deposits loans, and then we have here to check that this, when you call this function with these addresses, this raises an error in the RPC because it's not yet possible to use DUSD as collateral. Then because it's not, the 50 blocks are not over yet. Then we generate the 50 blocks, and which activates the DUSD, activates this transaction that we did before. And now we deposit DUSD to the vault. It runs through without an error, and it checks if the DUSD is actually in the vault as collateral now. which is the test is green, all the checks works. So we know this is possible now, or we ensured that this is possible. Nothing else to see here. So let's move on to the main thing that we want to look at, Payback DUSD. This is a bit more of changes, but honestly not that crazy. We had some discussions. I also had some discussions, or some recommendations or ideas. But in the end, it wasn't a huge merge request or a huge pull request. But let's look into it. Again, few more 100 lines, and the main changes in the linter, and we have tests coming in. We won't look at the tests right now because honestly, what's interesting for me and I think what's interesting for you is how does the code work, what changed. So where do we have a change? It's basically just in the master node checks CPP, and that's only one function. If you look into it, it's the execution of the payback loan message. So this is the function that is called when you send a payback loan transaction in a custom transaction on the chain. So this object that you get in here is the message. This contains the from what address do you pay back the loan, what vault in would you pay back the loan in, and what tokens do you want to pay back. Then existing code, we have the checks that the vault is active, that the collateral, whatever, everything is fine. And then we have the actual changes. One small note, we already have now with this update the governance tokens or the governance attributes, which is similar to the collaterals, to the active collaterals, where you can set flags kind of or attributes on the chain without needing to do a code change. It just sets the attributes and the chain knows if something is now set or not. And therefore you can activate or deactivate features without the need of a code change. And that's what's happening here. We say, okay, just allow the DFI payback. If it's active or not is a governance attribute. And you have here a nice block of code, which basically does nothing else but get from the attributes, from the governance attributes, the value if payback DFI is allowed. It is a bit of trouble to read because you get the attributes, then it's a lot of checks. If everything's fine, if everything's there, if there are attributes, if the attributes are set, if this attribute is there, if this attribute has a value, and then what the value is. Because you get the attributes, you get the key for the payback DFI attribute, you get the value of this key, you get the actual value of the key value. If it's there, you get what value is it set to, and if there is a value that it's set to, check if this value is true, and then you activate the DFI payback. So if anything happens, it's just not activated. Just a big thing to read. And then we come to the major thing. That's now where we go through all the balances, and balances means within this message that you send in, where you say I want to pay back into this vault from this address and those amounts, because I don't know if you know this, but you can pay back multiple tokens at once. So I can say I want to pay back now for this vault 100 DUSD, 0.1 Tesla, 1 SBI, and stuff like that. So you have a list of balances that you want to pay back. Till now, it was just like you go through this list, and for every token that you pay it back directly, and everything works fine. Now we have to change something in here, because if, and here's the interesting part, if we are blockade above Fort Canning Hill, and the first in this key value pair of balances, first is our token. The token ID is the token ID 0, and token ID 0 is DFI. So if we are above Fort Canning Hill and the token ID is DFI, then we do something special, or something different than before, of course. First thing to notice also, we have this key value pair first is token ID. Yes, we could have used here token ID instead of key value first. Yeah, it's not that big a difference. And we have the payback amount because the token ID and the payback amount will change later on, but we will see that. But it's interesting, they're different now. And we have this, we need a DFI USD price. So let's move on. If the DFI payback is not allowed or there is no DUSD token on the chain, then yeah, this is not possible, return an error. Now, it's always also this question, if you pay back a DUSD loan with DFI, what price for DFI is used? Because you need to convert those DFI into DUSD. It says, if you look into the DFIP, it says it should be at Oracle price plus 1% penalty. To be fair, Oracle price is not 100% specific, but it's pretty obvious what's the best way to do here, because let's have a quick detour into the Oracle price. If you see here, if you look at DeFi scan the Oracle, this is the live Oracle for the DFI USD. It's nice, it's going back up a bit. You have a current live DFI price of 3.62. This price is updated around every 15 minutes when Oracle send in a new price into the chain. That's what the most up-to-date price of the chain, Oracle price is that the chain knows of. The thing is now for the whole collateral and loan value calculations, we are not using this price, but every price block that's every 120 blocks, so around every hour, a price block, the current live price of the Oracle is fixed as a fixed interval price, and it's set into the next price for the fixed interval. And on this price block, the current next price is set to the active price. You see this in the Cryptosprungbrett pretty nicely. He added the Oracle price, and you see here, it's updating automatically. On the one hand, you see now the remaining blocks till the next price update. That's the price blocks. And currently, on the last price block, the live Oracle price was 3.59. Back then, the next price was 3.58, and that became the active price. And right now, from the actual price block to the next price block, this active price is the price, the Oracle price that's used for calculating the value of the collateral. So this means this active price is actually 1 to 2 hours behind the live Oracle price. But this is used everywhere. Two big benefits. First, you have a fixed interval price that everybody knows of, and you don't have to calculate the collateral and everything every second or every 15 minutes or whatever, whenever an update comes in. And the other thing is it creates a kind of stability for the Vault users, because it's not that because of a short price change everything goes bananas. It's more that you say, okay, I know already where my collateral, where my Vault collateral ratio will be in 1 hour and where I'm going. Therefore, you can take according steps to do that, and you have your certainty of what's happening. On the other hand, that also means it's a bit delayed. Since all prices and all collateral loan calculations use this price, this active price from the Oracle, it also makes sense to use this active price as the Oracle price that's referenced in the DFIP. But it means it's delayed, just so you know. And that's also for if you want to pay back the DFI, DUSD with DFI. Keep in mind that it's not the live price. It doesn't have anything to do with those prices, the tax prices, or the live Oracle price. It's really what counts is the current active Oracle price. Okay, back to the code. How do we get this Oracle price? In the code, it's pretty easy. You say, okay, use next price false, because we want the active and not the next. Require live price means that the Oracle needs to be active. So you can't do that when there is the Oracle is frozen or halted, because price changes or downtime of workers. And then we get this validated interval price. That's this fixed interval prices that you get from the CLI. What I just said, it's called the interval prices because it's a price for a fixed interval. So we get this DFI, and for the payer DFI USD. So we get this price, not the next, but it requires live. Get this value. If there's some problem, it's not live or anything, error, and we're out of here. Okay, we have the price, and now we have the second part of this DFIP where we say, okay, the Oracle price plus a 1% penalty. Again, penalty, the amount of the penalty or the size of the penalty is a governance variable. This means we get a default value and then again go in, get the attributes, get the key, and with the penalty key payback DFI %, get the value, the stored penalty, and here we have the 1 minus stored penalty. One major point is that within the whole source code, basically amounts are not floating points, but always interval values, integers, and it's always the 100 million scale up. This comes from the Bitcoin origin because Defichain source code is based on Bitcoin source code, and in Bitcoin, the smallest amount that you can represent is one Satoshi, which is one 100 millionth of Bitcoin, and in DFI we have same, we just call it Phi and not Satoshi, but it's again 100 millionth. That's why the penalty here is this weird number of 99 millions, because if you say 1 is 100, because it's everything represented in 100 millions, then 99 million is 0.99. And the coin, this is just a constant in the code, which is basically just 100 million. So whenever you see coin, it means 1. And we have here in percent stored penalty, again in percent as 100 millions. So we have 1 minus the percent, that's our penalty. The name is a bit misleading because this is not the penalty, this is the reduced by the factor reduced by the penalty. But okay, it's used in the correct way. So we have now the penalty, we know how much of the DFI price we use. So we have our actual use DFI USD price is multiply the result that we had before, that's the DFI price, the active Oracle price, times the penalty. Multiplying with this 100 million thing is not just times, but a bit of a calculation. That's why we have this helper function. So now we have the DFI price that we use. So the active Oracle price times this 99% from the penalty reduction is our used DFI price for the conversion. And then we say, okay, the token ID that we want to pay back is not as we have in the default from the amount we give in, because the balance that we gave in is DFI. We want to pay back DUSD. So set the token ID to DUSD, and the payback amount is now our price times the amount of DFI that we put in. Also, interesting thing to note, you don't define how much DUSD you want to pay back. If you pay back with DFI, you say, I want to pay back, I want to use 10 DFI to pay back a DUSD loan. And then internally, it calculates how much DUSD that would be, and then pays that back. That's why you put in here 10 DFI to pay back, and we convert this 10 DFI with the used DFI price to the actual amount of DUSD you want to pay back, and we say now you want to pay back DUSD. This check is just an overflow check that we don't have an overflow, and then we move on. The rest of the code here is what we already had. We say, okay, get the token ID, the loan token, get the amount that you had in this vault, so you know how much you could pay back, also the interest rates and everything. And then we calculate how much interest is to be paid back, because we always pay back first the interest and then we reduce the loan. So to check if there is still a loan to be paid back, if we subtract all interest. And here we see till now we had this key value second, which is the thing that came in, and now we need to use the payback amount because we need to use the calculated amount that we want to pay back. If we pay back less than the interest, we just pay back the interest and back as much interest as we can and no loan. But yeah, then we subtract the loan token and we say, okay, reduce the loan from the vault. Get that. And then we erase the interest, how much interest we really wanted. You see, okay, it's just this, that we use the correct token ID. And we calculate the new interest rate and everything. And then we have again some real code change. Okay, so far not that real or that much, because till now, when you pay back the loan directly with the token, it means there are less tokens circulating. So you need to subtract the amount of minted tokens for this thing, because if you take a loan in DUSD, you mint tokens, you create new tokens. And if you pay it back, those tokens get out of circulation. That's why it's reduced. If you pay it back with DFI, those tokens don't get out of circulation. They stay, so you don't want to do that. Also, we would reduce our own balance with this amount that we want to pay back till now, and then burn this amount, the interest. Take the amount of what was the interest, because the interest is not reduced from the circulating amount, but it's the interest that we pay back is taken, swapped over to DFI and sent to the burn address. So it's a constant buy pressure on the DFI just for paying back loans and pay the interest. And that's what's happening here, where we swap to DFI over USD and swap it to the burn address, which means it's burned. So this stuff is what happened before, or what should still happen if we don't pay back with DFI. So if we are before Fort Canning Hill, or we are not paying back with DFI, we do exactly what we did before, just now within this if. Submit the tokens, sub balance, and the swap over. If there's an interest to be paid, we swap over to DFI and burn. In the other case, where we now pay back with DFI and we are above Fort Canning Hill height, so we want to do that, it gets a bit simpler, because we just say, okay, we want to pay back with DFI. We don't need to subtract minted tokens, and we don't want to calculate if we pay back at interest or not. We burn all the DFI that we just sent in. Not all the DFI that we just sent in, because it could be that you overpay, and in case of overpay, you don't burn the overpay, you get the overpay back. So in case of payback amount is bigger than what we need to pay back, we have to reverse the calculation and say, okay, the amount that we pay back, the loan plus interest, divided by the used DFI USD price, is the amount of DFI that we need to pay back this amount. Then we have a small off by one correction. So if we have, based on the divide off by one, we overpay a little bit. So 1/5, that's why plus 1 means 1/5, 1/100 in millions. DFI, you overpay if you have not perfect calculation. But if you don't overpay, we will directly subtract what we put in. You say all the DFI we put in is used for the calculation. And then it's really simple, because it just moves your DFI from your address and the amount to the burn address. And the burn is done. And all the code is done. And that's it. That's everything that changed. Major takeaway from this, because there's a lot of talk about activating this for the D tokens. This is not done for the D tokens yet. Because of time pressure and everything, this thing was just implemented, as you see, for the DUSD payback. Because if we want to activate or have that for D tokens too, we need a new way of structuring this loan payback message, because this payback loan message that we are executing here just has one list of balances. So if you give in the Tesla, you pay back the Tesla. If you give in DUSD, you pay back DUSD. Now we added that if you give in DFI, we know, or we assume, that you want to pay back DUSD with this DFI. If we now want to say, okay, you can give in the DFI and you can decide what token you want to pay back, then we need an additional information in this whole message. So there will be probably a refactor, either a new message that you send in, a new transaction type, or a change in the type of this transaction that you can define. I want to pay back this token with DFI. So this is something where we need another fork, where we need another update. But right now, let's see how this whole thing goes. And then I think it's planned that this will be activated. Yusin said it's planned for the next update for the V3, Great New World, or Greater World, I don't know. But it needs a bit more of a refactor and a code change. So it's not activated or not activatable right now, not right away for the tokens. It's just done for DUSD, but done in a nice way for DUSD. And the other major takeaway that I want you to keep in mind, what price is used. It's not the live Oracle price, it's the current active Oracle price with a penalty of 1%. So the 99% of this price is what you actually use for paying back DUSD. Which in this case, just to have the comparison, right now, if you pay back the DUSD loan with the Oracle price, you get less than this amount, so 1% less, 3.52 or something. No, 3.55, I don't know, bad at math. But if you directly swap it to DUSD and then pay back, you get far more DUSD to pay back. So this is always if this price is more than 1% above this one, it makes sense to burn the DFI to pay back the loan. If it's below, it makes sense to buy the DUSD and then pay back the loan. So, Riasu, I hope this was interesting. I hope this helped some of you to understand it. If you're a developer, if you're a coder, please go into the repository and review the pull requests. There are many of them. It's really a lot of stuff going on, a lot of activation, a lot of activity in there. Helps everyone gets better. Everything helps. Read through the code. If you think something looks fishy, something is off, or something could be done better, make a comment. You always get a reply. They are super responsive and super helpful. That they say, okay, we did this because, or yes, you're right, could be done better. So it's a super community, also for the developer community. And the more reviews we have, the better we get, the less errors we have, the less bugs we have. The more stable the DeFi chain is, and the better our price gets. So win-win for everyone. Chime in. And if you like this, subscribe, leave a comment. I think I will do this more often in the future because I'm actively reviewing, so it's quite fun and might help someone and be interesting for you. If you have any feature that you want me to review or that you want me to explain, not new features, but existing stuff, how this works in the source code, how it's actually calculated stuff, leave a comment and we'll do a video and explain how this stuff actually works in the code so that you can use the DeFi chain better. So for that, have a great day and bye.